Did you hear a second moon? This needed investigation. This is the news at GeoCave. So hi and welcome to GeoCave. My name is Asha, I'm a geologist and I live in Norway. And on this channel I talk about anything geology related. But isn't everything geology related? Well, but sorry for my absence the last few weeks, but life has been in the way. But up towards December, I hope to post every second week. But let's see, I might sprinkle some stuff in here and there. Today we're leaving the Earth's surface and venturing out into space. We will look at the facts about the so-called second moon, kamo'oalewa. And we will use physics to see if it has any effects on the Earth. So grab a cup of your favorite drink and let's see what's in the cave today. When I heard the news that Earth has a temporary second moon, I was intrigued. What do we know about it? First, it's called 469219 kamo'oalewa or 2016 HO3, and it's actually a reasonable small-sized asteroid. And when I say small, I mean it has a diameter from 40 to 100 meters. That's the height of the Statue of Liberty or a high building. And it's not really going around the Earth per se, but it orbits around the Sun and has a period of 366 days, but it happens to be close to Earth the next 2 months, so astronomers can easily study it. I'm sad to inform that it will not be able to see with the naked eye. We know that the moon affects the tides, but the question is, does this small asteroid affect the tides? And even though the answer might be kind of obvious, I thought it would be interesting to look at the physics of it. So yeah, and just a little fun fact. Opposite to popular ideas, Newton's discovery of gravity didn't form from the falling of an apple, but him pondering about the moon's orbit around the Earth. And he came up with this equation for gravity, which is the force equals G times m2 times m1 divided by r squared, where F is the gravitational force acting between the objects, m1 and m2 are the masses of the objects, and r is the distance between the centers of their masses. And G is the gravitational constant. To calculate the moon's effect on tides, we are going to use this formulation, but we have to rework the equation a bit. So we'll just have tides here. I'll just remove this and this and put a 2 here. Big M, small m are 3. The big M is the mass of the celestial body, and the small m is the mass of the objects experiencing the force. To get an idea of the effects of the asteroids kamo'oalewa on the Earth, we are going to compare it with the moon. We do this by taking the ratio between the force tides of the two. So let's write it on the board here. Let's just see here. So we're just going to, I think we will write it here because like this was so messy. Okay, so we have that the force of the from the kamo'oalewa, and the force of the moon. And that equals to 2g cam divided by d cam 3, and then you have over here, you can, instead of dividing it, you can multiply it with the invert equation here. So you have d3 moon over 2g, oh yeah, we have to multiply with an m here, 2 moon times m. Okay, I don't know if you could even see that, but yeah, anyways, and then that becomes m cam times d3 moon divided with d3 cam multiplied with big moon. Okay, and yeah, and that is, as you see here, can you even see it? Yeah, okay. And that, and you just have to trust my values here. So the values here is then 1.14 times 10 to the 10th times 3.84 times 10/8 in third divided with 7.35 times 10 to 22 and 4.6 times 9 and third. And that equals to 1.11 times 10 to the minus 16. Yeah. So what can we conclude from this? Well, the tidal force exerted by kamo'oalewa on Earth is approximately 1.11 times 10 to the minus 16 times that of the moon. This extremely small ratio indicates that the kamo'oalewa effects on Earth tides is negligible and undetectable. If kamo'oalewa, on the other hand, crashed into the Earth, it would make quite an impact. But as far as I understand from astronomers, there is no dangers of that. So that's the news for today. If you have any thoughts, leave a comment below. I will soon post a second video in the course on paleomagnetism. But until then, have a rocky day! This is the news at UK.